Welcome to Brain Beans. It's your host here. Hi. Today's topic, the unsung hero of cleanliness. Well, of course, I'm talking about soap. So, something we use every day, often without thinking about its magic. Whether we are washing our hands, showering, or doing laundry, soap is an essential part of our daily routine. But how much do we really know about the humble bar of soap? Today, we are going to take a deep dive into what soap is, how it works, why that it's so important, and its environmental impact. Trust me, by the end of the video, you're going to appreciate soap more than ever. Let's start with the basic. What is soap? At its core, soap is a cleansing agent made from natural oils or fats and an alkyl, also known as a base like sodium hydroxide. But it wasn't always so simple. The earliest soaps date back to thousands of years. The ancient Babylonians around 2800 BCE were mixing animal fats with wood ash to create a crude form of soap to clean wool and cotton. Jump ahead to 1500 BCE. The Egyptians were using a mix of animal oils and alkaline salts for both personal hygiene and medical purposes. By the time Romans come around, they were using a mixture of goat tallow and bleach wood ash for soap, which was considered quite revolutionary. In fact, the word soap comes from the Roman legend of Mount Sapo, where animal fat mixed with wood ash and rainwater, creating a substance that was surprisingly effective for cleaning. Now let's dive into the chemistry of soap. Oh, don't worry, I promise this will be fun. The chemistry of soap. Let's meet the golden retriever and the cat. You may be probably wondering what the hell is that, right? Let me explain. Imagine it's a bath day of two pets, a golden retriever and a cat. The golden retriever loves water and jumps right into the tub, splashing around with excitement. Meanwhile, the cat, it's doing everything it can to avoid getting wet, clinging into the edge of the tub like its life depending on it. This dynamic duo is the perfect metaphor for how soap works. Let me explain. Soap molecules have two very different personalities. First one is the golden retriever side of the molecule is called hydrophilic. It loves water. This is the head of the soap molecule and it bonds easily with water molecules. The cat side of the molecule is called hydrophobic part. This hates water but loves grease and oils. This is the tail of the soap molecule and it attaches itself to dirt, grease and grit. When you introduce soap into a bath, these molecules form tiny teams called micelles. The hydrophobic cattails huddle together, grabbing into the oil and grime like they are refusing to touch the water, while the hydrophilic golden retriever heads happily face towards the water. As you rinse, the micelles carry away the oils and dirt, leaving the surface clean. It is like golden retriever helps drag the stubborn greasy cat into the water and washes everything down and drain. And that's how soap works, a perfect balance between its golden retriever and cat sides teaming up to clean the messiest situations. For all the nerds like me out there, I'll explain the animal incident short and sweet. Soap works because it has two very special ends. It's made of molecules called surfactants, and each molecule has a hydrophobic, aka water-hating tail, and a hydrophilic head, also known as a water-loving head. Here's the cool part. When you add soap to water, the soap molecules arrange themselves into little clusters called micelles. The hydrophobic tails grab onto oils and grease, while the hydrophilic head stick to the water. This allows water to rinse away the dirt and oils that would otherwise stick on your skin or clothes or dishes. The magic behind soap is a chemical reaction called saponification. This happens when fat or oils, also known as triglycerides, react with sodium hydroxide, producing soap and glycerin. Glycerin is a moisturizing byproduct. The triglyceride molecule is made out of glycerol and fatty acid. When sodium hydroxide breaks the bond, the fatty acid form soap molecules and glycerin stay behind as a natural moisturizer. So here's the million-dollar question. Do we really need soap? Can't we just use water to clean everything? Well, water alone is great for rinsing away dirt or sweat from your skin. But soap is necessary for cleaning oils, grease and germs. Why? Because water and oils do not mix, but soap helps them to mix. The hydrophobic tail of the soap molecule binds to the oil, while the hydrophilic head binds to the water, allowing us to wash away grime that water alone can't touch. Soap also has the power to kill germs. Most bacteria and viruses, including the ones that cause illness, have a fatty outer layer. Soap breaks down this fatty membrane and helps to wash the microbes away. It's why the CDC recommends washing your hands with soap to reduce the spread of diseases. Now let's talk about the environment. Can soap be eco-friendly? Soap is biodegradable, and when we made with natural ingredients, it's generally eco-friendly. The problem comes when soap contains synthetic additives, fragrance and preservatives which can harm ecosystem. As example, palm oil commonly used in soap has been linked to deforestation, threatening wildlife habitats. But don't worry, there are alternatives. Like castile soap, made from olive oil, is a fantastic, sustainable option. And you can also use Rita, also known as soapnuts, a completely natural, biodegradable alternative that's been used for centuries in India for laundry and personal care. If you want to reduce your environmental impact, look for soaps with sustainable ingredients, or even make your own. The future of soap is green, and we can help shape that future with every bar we choose. For the chemistry lovers out there, let's explain the saponification process in more detail. Imagine a triglyceride, which is a molecule made up of 3 fatty acids and a glycerol backbone. Now, when we introduce sodium hydroxide, the chemical reaction happens in 2 key steps. First one is breaking the ester bond. Sodium hydroxide breaks the bond between glycerol and fatty acids. Second one is formation of soap. The fatty acids from sodium salts, which are the soap molecules, while glycerin or glycerol is left behind as a byproduct. The reaction looks something like this. Yes, look above. The soap molecules that are formed are what we use to clean, while glycerin is often used in lotions because it's super moisturizing. So we have covered the basics of soap, but you may be wondering what is the deal with HCl and sodium chloride. HCl, aka hydrochloric acid, is something used in soap making process to adjust the pH of soap, ensuring it's not too alkaline. Too much sodium hydroxide would make the soap harsh on your skin, so HCl can help to neutralize it. Next up is table salt, also known as sodium chloride, is used to help solidify the soap. When sodium chloride is added to the soap mixture, it helps the soap harden and become easier to handle and store. And there you have it, soap in all its glory, from its ancient beginnings to cutting-edge chemistry that make it work. Soap is not only a cleaning tool, but it's also a catalyst for health, protecting us from germs and helping us to maintain hygiene. So, next time you wash your hands or jump in the shower, take a moment to appreciate the centuries of innovation that went into making this everyday wonder. And remember, whether it's castile soap, soapnuts, or homemade soap, you can choose an environmentally friendly option that works just as well, and maybe even better. So that's it for today. Stay clean, stay green.